Hey everyone, we are going to do factoring with a not equal to 1 today. And again, we're a little bit ahead of the other classes on this, so this will be a very short video and then you can begin on your Delta Math. I have Unit 3, Day 6 notes in front of me, but we're only going to do 4 of the problems. So you guys stick with me on this and then you'll have some things that you can post on the discussion board. So we're going to do this first one. You guys will remember that the first thing we always look for when we're factoring is a GCF. Sometimes the equation has a GCF, sometimes it doesn't. In this case, 2x squared, 5x, and 3, the only thing they have in common, their only common factor is a 1. So it doesn't do us any good to factor that out. So we'll skip the GCF step and we'll go directly to the step where we are multiplying a and c together. So a times c, a you remember is the coefficient on the x squared, not the x or the square, just the coefficient. So a in this case is 2, and c, that's the constant, that's the one here. So that's 3. 2 times 3 is 6. So my task is to think of two numbers that multiply together to be 6 and add together to be 5. Well, I only have a couple things that multiply together to be 6, 1 and 6, or 2 and 3. And these would add together to be 7, so it must be those that add together to be 5. All right, let's substitute those in. So we're going to take and substitute those for the b term. Remember, the a term and the c term stay like they are, and the b term is going to change. So I've got 2x squared. And now, instead of plus 5x, I'm going to put plus 2x plus 3x, and then the c term stays the same, plus 3. All right, let's imagine that there's a line right here. I'm going to focus just on these two. The GCF of 2x squared and 2x, well, 2 goes into both 2 and 2, and I see that they have an x in common, and I'm always going to pick the lowest exponent. The lowest exponent between 2 and 1 is 1, so 2x is my GCF. And let's see what we get when we factor that out. So factoring is really just division. 2 divided by 2 is 1. I'm going to put the 1 there. You can choose to put it or not put it. In this case, it doesn't matter. And then I'll look at my variables. I have x squared, and I'm factoring out an x with that understood 1 of exponent. So remember, you subtract your exponents when you're dividing. 2 minus 1 is 1. So I'll have x to the first right there. Again, I can choose to put that exponent of 1 or not put it. It doesn't really matter. Usually we don't. All right, now let's do this one. So 2 divided by 2 is 1, and x to the first, the x cancels out completely. So you might be tempted just to close your parentheses right here. But remember, when we factor, we ought to be able to distribute this back and get the same thing. So I can't just close my parentheses after 1x, because 2x times 1x is 2x squared, and this term would be lost. I have to put the 1 in this case. 2 divided by 2 is 1. I need two terms in the parentheses because I had two terms in this original part of the expression. So I'll close my parentheses there. All right, now let's look at these. 3x and 3. What will go into both of those? Well, I can see that they have a common factor of 3. 3 divides into both 3 and 3, but I cannot put an x here because this one has an x and this one doesn't, so they don't have x in common. So I'll put my parentheses there, and then I'll divide. 3 divided by 3 is 1. I'm going to choose not to put the 1 this time, but I do have to put the x. And then for this one, 3 divided by 3 is also 1. Okay, we talked about this in the last video. If you look in the parentheses, x plus 1 and 1x plus 1, I wanted to put those different from one another so that you can see that even though they don't look exactly the same, they do have the same value. 1x plus 1 and x plus 1 are the same. So that's what's going to go in my first parentheses, x plus 1. And then in my second parentheses is what's on the outside here, 2x plus 3. That's going to go here, 2x plus 3. So that is my factored form of this. And if you remember, if I were to multiply this back together, if I were to FOIL it out, x times 2x would give me 2x squared. X times 3, well, that would give me 3x. 1 times 2x, that would give me 2x. And 1 times 3, that would give me 3. So you can see that it would turn back into this if I multiplied it together, and if I combined like terms, it would turn back into this. So the way I would check these is I would use my distributive property, or I would use FOIL, and I would multiply these back together and turn it back into this. Again, we talked about this in the last video. My understood exponents on both of these is 1. That's what I'm hoping to have because I need to be able to find the x-intercepts, and I'm going to use this property to do that for my quadratics that I'm going to graph. Okay, let's come over here to number 2. So again, I look for a GCF. Always start with a GCF, 5x squared, 9x, and 2. The only thing those all have in common is 1. It doesn't do me any good to factor out a 1, so I'm going to do my AC. A in this case is 5. It's the number in front of the x squared, not the x squared itself. And C is negative 2. Don't forget to bring that negative with it. That's really important. 5 times negative 2, negative 10. Okay, so if I look at the things that multiply together to be 10, I have 1 and 10, and I have 2 and 5. Somehow I need to get a negative 9. Well, if I look at 2 and 5, it doesn't matter which one of those I make negative, I'm not going to be able to come up with a 9. But if I look at this one, I make one of them negative, I will be able to come up with a 9. If I make my 1 negative, negative 1 and positive 10, that makes positive 9, which is not what I want. So I want to put my negative over here on the 10. Positive 1 and negative 10 make negative 9. So now I have the two numbers that I need, and I'll substitute in. I'm going to leave the 5x squared just like it was, and then I'll substitute in plus 1x, and that 1 is optional. It's understood to be there if I don't choose to write it down, minus 10x minus 2. Okay, so now let's cut that in half. Remember, we've got that understood imaginary line right here. Look at these first two. What they have in common is just x, so I'm going to factor out an x. When I factor out an x, there's an understood 1 in front of it that I'm dividing by. 5 divided by that understood 1 is 5. And here I have x squared. That's x to the first. 2 minus 1 is x. And then 1 divided by 1 is 1, and just like I explained on the last one, I need to have that 1 there so that I'll have two terms in the parentheses to match the two terms I had here. Okay, and if I look at these, I've got positive and positive, and here I've got negative and negative. I need them to match, so when I factor out the GCF here, it's going to have to be a negative 2, not a positive 2, because I need to be able to change the signs. Negative 10 divided by negative 2 is positive 5x, and negative 2 divided by negative 2, positive 1. Okay, well, what I have in the parentheses is the same. That's what I was hoping for. So I'm going to put that here, 5x plus 1. And then in the second parentheses, I'll put what I had on the outside, x minus 2, coming from in front of both of those parentheses. And so that is my factored form of this quadratic. If I multiplied it back together, because those are factors, if I multiplied it back together, I would get this. Okay, let's skip down here to number 5, which is going to be our third one. And when I look across this one, 3x squared, 6x, and 9, I can see that this one does have a GCF of 3. So I'm going to factor that out first. X squared, because 3 divided by 3 is 1, plus 2x, 6 divided by 3 is 2, minus 3, because 9 divided by 3 is 3. All right, and now I'm ready to do AC on what I have here. So when I do this, I ignore the 3 in the very front. Once I factor it out, I don't need to use it anymore, but it is still part of the answer. It's really important that it comes down with it. So A is going to be the understood 1 that's in front of the x squared right here. I have an understood 1. And then C is going to be this negative 3 over here. 1 times negative 3 is negative 3. So I need two things that multiply together to be negative 3 and add together to be positive 2. I don't look back up here. I focus here inside the parentheses. So what multiplies to be 3 is 1 and 3. I need it to be a negative 3, so I know one of these is going to have to be a negative. And when I add them together, I need to have a positive 2. So if I put my negative here, negative 1 times 3 is negative 3. Negative 1 plus 3 is positive 2. So that's everything I need. I'll substitute in. And when I substitute in on this, that 3 that's on the outside just stays right there on the outside. I don't do anything with it. I just let it stay there. And I'm going to type all the other things in. All right, substituting for that positive 2x, negative 1x, and positive 3x. All right, I'll cut it in half. Again, that 3 that's on the outside just stays. It's part of the final answer, but it doesn't affect when I have to do the GCF of these two, which is going to be x. And what I'll have in the parentheses, x minus 1 there. And then I'll do the GCF of these two, which is going to be positive 3. And then what I have in the parentheses, x minus 1. And now I'm ready to write my final answer. That 3 just stays there. What I have in the parentheses is the same. And then what I have outside the parentheses is that x plus 3. Okay, last one. So this one I wanted to do with you because it's a little bit different. If I look across for my GCF, 2, 4, and 2, well, those are all divisible by 2, so 2 is part of my GCF. But if I look closely, I can see that they also all have a variable of x. So x will be part of my GCF in this case as well. And then when I factor that out, 3 minus 1, 3 exponent right there, subtracting the 1 exponent that's right there, well, that's going to be x squared. And then I have plus 2x, 4 divided by 2 is 2, and I'm subtracting 1 on the exponent for this one that I factored out, plus 1 there on the end, because 2 divided by 2 is 1. All right, so now I'm ready for AC. A in this case is the understood 1 that's in front of the x squared. Oh, let me go back and put my equals in there. And C is the constant right here. 1 times 1 is 1. Well, this one's not bad. There's only two things that multiply together to be 1, and that's 1 and 1. And 1 plus 1 is 2. So I have my numbers that I need. That 2x stays on the outside. And then on the inside, I'm going to have x squared. And I'm going to replace that 2x with plus 1x, plus 1x, plus 1. All right, and these two 1s in front of the x's, those are understood to be there. You don't have to write those, but this one you do. The constant you have to write down. All right, let's cut it in half. So the 2x, again, just stays on the outside. And I'm going to factor an x out of these two because I can see that they have an x in common. All right, and now I'll look at these two. They have only 1 in common, and I'm going to go ahead and write that down even though it's understood to be there because that's going to help me in the next step to keep my thoughts organized and to have everything that I need. So that 2x on the outside just stays. And then on the inside, I have x plus 1. That's in common to both of those. And then in the other parentheses, again, I have x plus 1. And then remember we said last week that if you wanted to, you could rewrite this as 2x. And because I have x plus 1 on both of those, I can put x plus 1 to the second power. This part is optional. You have to write this. This part is optional. I just want you guys to see it in case you need it for standardized testing or other things that you have coming up in your future. All right, so that's all we need to practice today as far as factoring when A is not equal to 1. You guys can go ahead and do your discussion board post and get started on your Delta Math.